All right, so it's a couple of minutes after 12, so we'll wait for maybe 1 or 2 more minutes for folks to trickle in, and after that, we'll get it started. And we do have the full panelists, presenters are here, so we're almost ready to go. And while we are trickling in, I'm going to go ahead and share my screen. All right, just a quick check. I know some of the attendees might not be able to, are not able to speak. So the panelists, are you guys seeing the screen that I'm sharing? So you can, okay, great.
Yes.
Okay, let's go through this view. All right, so I believe we have quite a lot of attendees. So before we go through the presentation, let's go through the ground rules, and we'll do the proper introduction. So the first thing, please go ahead and change your name to add your school abbreviation behind it. For example, Jane Doe, if you're from UCLA, dash UCLA. That way we can kind of understand where, which schools you're coming from. The questions will be answered at the end of the presentation. The questions will be kind of broken down into 2 piles. One will be technical related questions on the presentation itself. We also have a presentation on the hiring and positions with the LA Sanitation. So some of the questions that are related to the hiring, and they will be answered in a separate pile. So feel free to use the Q&A button at the bottom of your screen. Go ahead and type in, and we'll call your questions as in the order we receive them. After the Q&A, we'll go into another slides, series of slides that will go over the hiring and additional information. And most importantly, as with any professional setting, anyone exhibiting unprofessional behavior will be removed and be reported to Zoom as well as your school. So please, follow the rules of the professional conduct. All right, so with that, today is October 18th, a beautiful Tuesday in Southern California, and I am Ryan Thiha, will be your host and moderator for the presentation today. So again, welcome to LA Sanitation Environment Tech Talk series. Today is the second of the 6 Tech Talks that LA Sanitation is hosting. Today with me on the screen, you see Ms. Lisa Thamis. She's our student engineer. She will be the co-host, assisting with the technical part of it. We also have our marketing manager, Ms. Pam Perez, who is the lead for getting everything going on. So just a background on our Tech Talk, we have a series of Tech Talk with 6 segments. Today is the second of our series. And today's program will run for about an hour. The presentation itself will be about 30 minutes, which will be followed by Q&A and some general information. After the presentation, we will read out your questions, and Nasir or Kimia or myself or other panelists will respond to your questions based on the order we receive and based on the category. So before we go into the presentation, I wanted to take this opportunity to introduce the two presenters that we have today. The first presenter is Ms. Kimia Naratirani and Mr. Nasir Emami. So they'll be our presenter for today. And starting with the first presenter, Mr. Emami. So I'll just call you Nasir since we've known each other for a while. So I've had let me go to the slide. There you go. There we're on the right slide. So I've had a pleasure and privilege of working with Nasir for over the last, I would say, 15 years. A good friend of mine. Nasir started his career in the energy industry, in the petroleum, and then he joined LA Sanitation as environmental engineering associate in the stormwater portion of our program. Subsequently, he moved into wastewater engineering services part, where he did a lot of planning engineering in the collection system. The latest work that Nasir is leading is the Hyperion 2035, where city is trying to achieve 100% recycling for all our wastewater that city generates. So Nasir is the technical lead for membrane bioreactor and the whole program itself. So that's our colleague Nasir. Now moving on to Kimia. So Kimia is one of our newer engineering associates. She has a lot of background in environmental engineering. She's basically graduated of UC Davis and UCLA. She joined city team probably about 6 years ago, right, or even more. And she is very active in outside organizations, trade organizations such as Engineers Without Border, SW, and the Graduate Student Association, where she helped and assists fellow graduates and students to become professionals. So those are the two presented for today. So with that, before I go to the next slide, I'll hand it over to Nasir and Kimia for your presentation. So let me stop the share and allow you to share your screen.
All right, Kimia is going to share the presentation. All right, thank you, Ryan, for the great introduction, and welcome everyone. My name is Nasir Emami. Just to add to what Ryan mentioned, I started my career as an environmental engineer in 2001, working for a consulting firm called CH2M Hill, designing water and wastewater treatment facilities. And as Ryan mentioned, in 2004, I joined the city of Los Angeles, Bureau of Sanitation, and I've been with many programs in the city of Los Angeles since, including Watershed Protection Division, Wastewater Engineering Services Division, Environmental Engineering Division with Los Angeles Bureau of Engineering, and currently Water Recycling Implementation Division at Hyperion. And with that, I'll hand it over to Kimia.
All right, thank you, Nasir, and thank you, Ryan, for the introduction. My name is Kimia Nader-Tehrani. I'm an Environmental Engineering Associate 3 with LASAN. So a bit about myself, I started working for LASAN about 4 years ago. I started off in the process engineering group at Hyperion Water Reclamation Plant, and I've been working in the Water Recycling Implementation Division for the last 3 years. So first, we wanted to just give you an idea of some of the job responsibilities as an environmental engineering associate in LASAN, and specifically the Water Recycling Implementation Division. So our job responsibilities and day-to-day activities include working on projects through the pre-design, design, and construction phases. We work on conducting technical studies and pilot testing of advanced treatment technologies. We work on reviewing existing and proposed regulations for water reuse, as well as preparing the environmental documents, for example, for CEQA and EIRs. In addition, we also participate in outreach activities with the scientific community, NGOs, as well as community members. And just to explain the importance of the projects that we're working on, the water recycling projects, I wanted to take a moment to talk about the drought that we're currently facing in California. So as I assume most of you are aware, California has a long history of dealing with droughts. And it seems like, every year is getting hotter and drier. And actually this year, 2022, is one of the hottest and driest years in California's recorded history. So Southern California and the city of LA, we receive over 80% of our fresh water supply from faraway sources like from Northern California and the State Water Project, as well as the LA Aqueduct and the Colorado River. And one of these sources is Lake Oroville. So to give you a visual representation, these are a few photos of Lake Oroville over the last decade or so. So you can see how much this reservoir has dried up in the last decade, which is really scary to think about. So we definitely, as a city, our main goal is to end up recycling 100% of the wastewater coming into the city by the year 2035. And this map just shows where LA currently gets its freshwater supply. So again, the majority comes from the State Water Project, Colorado River Aqueduct, and the LA Aqueduct. Currently, we get about 17% of our water from local sources. So about 15% from groundwater and about 2% right now is from recycled water sources. Again, we want to work on eventually recycling all the wastewater coming in, and that can help us become more resilient to droughts and also other natural disasters like earthquakes that can have an impact on our water infrastructure in the state. So the evolution of water reuse. So to provide you with some history, water recycling and reuse has actually been around for a very long time. There's actually evidence of agricultural irrigation with wastewater back in 3000 BC in Greece. And then beginning in the 20th century, planned water reuse became very important as a way of conserving our freshwater sources. So landscape irrigation became more common. And then in more recent years, industrial reuse and groundwater recharge have also become more available. And since advanced water reuse technologies have improved, we've also been considering indirect potable reuse, which is implemented in some areas, as well as eventually direct potable reuse. So regulatory agencies like the State Water Resources Control Board in California are working on finalizing regulations for direct potable reuse currently. And this schematic shows the process for indirect potable reuse, or IPR. So the idea is that wastewater that comes from residential, commercial, and industrial sources, after it goes through conventional wastewater treatment, it would go through advanced treatment as well. So there's two types of indirect potable reuse that we're talking about here. The first type is groundwater augmentation. So following the advanced treatment, the water could be spread or injected into a groundwater aquifer. And then the other type of IPR involves surface water augmentation. So both of these options essentially provide an additional environmental buffer following the advanced treatment. And after a certain amount of time, approximately a couple of months for groundwater augmentation and several days for surface water augmentation, the water would be sent to a drinking water treatment plant, and then it could be distributed back to the city. And this is a schematic for direct potable reuse. So this is what we're working towards eventually. There are two types of DPR that we can talk about too. So there's raw water augmentation and treated drinking water augmentation. So for raw water augmentation, again, following wastewater treatment and advanced treatment, the water could be sent directly to a drinking water treatment plant and then distributed back to the city. And for treated drinking water augmentation, following the advanced treatment, that water would be considered clean enough to enter the drinking water pipelines directly and be distributed. So now to get into an overview of LASAN's Clean Water Program and how we've implemented some of these water recycling programs, as well as what our plans are for the future. So as I assume you know, wastewater is generated from residential, industrial, and commercial sources. So if you live in the city of LA, if you take a shower or flush the toilet, brush your teeth, the wastewater is going to end up at one of the 4 water reclamation plants within the city. So LASAN, we also have extensive pre-treatment programs where we work with industries to make sure that what they're putting into the sewer system meets certain requirements. And that's to make sure that we can treat the wastewater reliably. And that helps us protect our water reclamation plants as well. So the wastewater then flows through pipelines, either through gravity flow or through pumping stations, and goes to the water reclamation plants for treatment. And currently, the treated wastewater could be either safely discharged to an ocean or a river, or it could be reused for a variety of purposes, like industrial use or cooling water, as well as seawater intrusion barriers. And then the city's goal is to ultimately close this loop and redistribute the recycled water back to the city. So this map shows LASAN's service area. So LASAN serves a population of over 4 million residents with an area of approximately 600 square miles and a sewer system length of 6,700 miles. We operate 4 water reclamation plants. So there's Donald C. Tillman, LA Glendale, Hyperion, and Terminal Island. And this table can give you an idea of the current water recycling efforts within the city. So as you can see, we're currently recycling approximately 119 MGD out of a little over 300. MGD stands for million gallons per day. So these sources of recycled water are used for a variety of purposes that you can see in these photos. So here, this top photo is the Japanese garden at DCT. So that's one of the uses of recycled water. This over here, this is the Hyperion Bioenergy Facility, where we send some of the recycled water from Hyperion. You can see the LA River as well. And these are some of the examples of advanced treatment at the Terminal Island Water Reclamation Plant. So as you can see, we're currently recycling about 73 MGD at Hyperion, and we want to eventually be able to recycle everything that's coming into Hyperion Water Reclamation Plant. And at this point, I'll pass it back to Ryan. I believed he had some questions for us.
All right, so I was able to successfully unmute myself. So I wanted to interject because I have such a strong interest in water recycling, which is really exciting effort that we're undertaking. But you know, when you're talking about wastewater, my understanding is that it's not really considered waste anymore, right? We're trying to recycle, reclaim it back. So what do you call it nowadays? And my follow-up question, you know, is if we're going to reclaim it, what are the resources that can recover from the wastewater? Maybe we'll cover that in the next slide, but you know, maybe that might be something that we all have in common. So I look forward to hearing from Nasir for the rest of the presentation.
All right. Thanks, Ryan. Excellent point and good question. So as you mentioned, you know, in recent years, there has been a paradigm shift, right? So wastewater is not considered waste anymore. It's considered a resource. And in fact, it is a resource, right? So that's why that a Hyperion Water Reclamation Plant, we call it Hyperion Water Reclamation Plant. We used to call it, not too long ago, we used to call it Hyperion Wastewater Treatment Plant, but not anymore. So now we call it Hyperion Water Reclamation Plant. And Some of the things that we can recover from wastewater could be water that Kimia mentioned right earlier. And in fact, we're going to convert Hyperion to a 100% potable reuse facility by 2035, which I will be talking about it. Also, biosolids that we can use for land amendment and fertilizers, and also biogas. So we can produce biogas, which has a high content of methane, and use that to generate energy, electricity. So yes, there has been a paradigm shift. So it's in fact, wastewater treatment facilities, they are resources recovery facilities. So we don't call them wastewater treatment facilities for the most part. So I'll be talking about Hyperion first. So Hyperion has been in operation since 1894. It's one of the largest wastewater treatment plant in the world. Hyperion has a design capacity of 450 MGD. MGD stands for million gallons per day. So whenever I say MGD, it's million gallons per day. So as I mentioned, Hyperion has a treatment design capacity of 450 MGD for dry weather. For wet weather, it's 850 MGD, million gallon per day. And hydraulically, in terms of how much flow can pass through Hyperion, it's 1 billion gallon per day, roughly, right? So over here, we mentioned that it's a full secondary treatment system or facility utilizing high purity oxygen. So full secondary treatment is, I don't want to make it too technical, but it's a biological treatment. So we take advantage of microorganisms and we supply them with oxygen or air in the right environment and they break down organics, different contaminants, and they reduce pathogen concentrations. So that's what we mean by secondary treatment. So effluent discharged from Hyperion, effluent in wastewater terms, we call discharge effluent. So that's another term. So effluent treated or treated discharge from Hyperion, for the most part, it's discharged into the Santa Monica Bay through a 5-mile ocean outfall. And Hyperion includes a solid processing system, which I mentioned earlier. That is to treat solids and produce biosolids, and also using what we call the egg-shaped digesters to produce biogas, to eventually generate energy and electricity in Hyperion bioenergy facility. So just a snapshot of Hyperion. So next slide, please. Okay, so this slide shows a schematic for the treatment process at Hyperion and a typical wastewater treatment plant, right? So we have the inflow, which we call it influent in wastewater treatment terms, wastewater sewage. So the first treatment process is what we call preliminary treatment. Preliminary treatment includes some bar screens and grid chamber. This is mainly to remove large debris and to protect downstream treatment processes from those large debris and abrasive particles, right? To protect mechanical equipment and downstream treatment processes. So that's the first treatment step, preliminary treatment. After that, we have primary treatment. So primary treatment is to remove suspended particles and some of the pollutants and organics through some large basins by gravity. Why do we prefer gravity? You know, because gravity is for free, right? So we don't have to consume energy. So it's a very effective way of, an efficient way of removing some of the particulate solids, primary clarifiers. Then after primary treatment, we have secondary treatment. As I mentioned earlier, it's a biological treatment, and we take advantage of some microorganisms to remove organics, contaminants, and pathogens. So it has two components. Secondary treatment has two components. One is called oxygen reactors, or what we call bioreactor. And the second component is what we called final clarifier or secondary clarifier, right? So one is a bioreactor, one is again a settling basin, which we call secondary clarifier. So at this point, the treated water, we call it secondary effluent, right? Or secondary discharge. So for the most part, we discharge that secondary effluent into the Santa Monica Bay, as I mentioned earlier, to a five-mile ocean atoll. We recycle a portion of that secondary effluent. We supply that water to another agency, West Basin Municipal Water District, and they provide additional treatment, and they produce even a higher quality recycled water for various applications, industrial, landscape irrigation, seawater barriers, etc. So that is approximately the amount that we send to West Basin is approximately, on average, 35 million gallons per day, right? So a fraction of secondary effluent, we use another treatment process at Hyperion. We call it tertiary treatment, which includes filtration and disinfection. And we provide further treatment on the secondary effluent, and we use that water, the tertiary treated water, for in-plant utility use at Hyperion. So for beneficial use at Hyperion, such as for in-plant wash, a facility that produces oxygen for the bioreactors, we call it cryogenic facility, and Hyperion bioenergy facility that I mentioned earlier. Next slide, please. All right, so earlier, Kimia talked about climate change, all the challenges that we're facing, right? Drought and water scarcity. So in California, imported water is not a reliable and sustainable source due to seismic vulnerability, climate change, drought, and environmental impacts at the source, right? So it makes sense to maximize supply from local sources, mainly recycled water that Kimia mentioned earlier. So in February 2019, our mayor Eric Garcetti, announced Hyperion 2035. So Hyperion 2035 program is to recycle 100% of all Los Angeles wastewater by 2035, and to source up to 70% of all water locally by 2035, right? So right now, approximately 85% of the water that we use in City of Los Angeles comes from, is imported, right? So from California Aqueduct and Los Angeles Aqueduct and Colorado River, that Kimia mentioned earlier. So those are, the objectives: recycle 100% of wastewater by 2035, and sourcing up to 70% of all water locally by 2035. And so for specifically, for Hyperion, our plan is to transform Hyperion to a 100% advanced water purification facility that produces potable reuse water, right? So it's not just for beneficial use, it's high quality for potable reuse by 2035. Next slide, please. All right. So our Hyperion 2035 has various components. So right now we're constructing two projects. One is Hyperion MBR. MBR stands for Membrane Bioreactor. Hyperion MBR Pilot Facility. This project is the proof of concept and cornerstone for the big project for Hyperion 2035. The other project is Hyperion Advanced Water Purification Facility project. This is not Hyperion 2035. This is a small scale advanced water purification facility that produces up to 1.5 million gallon per day high quality recycled water for beneficial use at Hyperion and LAX. So beneficial use such as industrial application and toilet flushing. So our program has other components as well. So technical studies, to identify effective and efficient treatment technologies for Hyperion 2035, and the conversion to Hyperion 2035 while keeping Hyperion, the existing treatment process, fully functional, right? Because we cannot shut down Hyperion, when we're doing the transformation, conversion. We are, as I mentioned earlier, we're receiving a lot of wastewater, right? Design capacity of 450 million gallon per day, on average daily flow of 270 million gallon per day. So we have to keep the facility fully functional during the conversion and during the transformation. So, and that's one of the goals of the technical studies, right? So program planning, pretty much planning for the future transformation and conversion, CEQA and permitting. So CEQA is to inform government decision makers and the public about the potential environmental effect of proposed activities as part of Hyperion 2035, and to avoid any environmental damage. So that's the purpose of CEQA and all those permitting. And then lastly, an outreach component, right? So public outreach is an integral component of Hyperion 2035, just to ensure that the public understands and supports Hyperion 2035 program, 100% potable reuse conversion. Next slide, please. All right, so I talked about MBR pilot project earlier. And again, as I mentioned, this is the proof of concept and cornerstone for Hyperion 2035. So this project, this is a 1 million gallon per day project. It's a joint effort between LA Sanitation and Environment, Los Angeles Department of Water and Power, and West Basin Municipal Water District. And the objectives of this project is to obtain regulatory approval for potable reuse application as part of Hyperion 2035, to compare different membrane bioreactor treatment technologies side by side, and also to develop design and cost criteria for the future project, Hyperion 2035. So key treatment components that we're testing as part of this pilot are membrane bioreactor or membrane separation systems. These are like spaghetti-like membrane systems. Then followed by reverse osmosis, followed by what we called UV advanced oxidation process. So those are the core of treatment process for MBR pilot and for the future Hyperion 2035 facility. Next slide, please. Here is another schematic, for this is the process flow diagram for Hyperion MBR pilot facility. So feed to the facility or influent, in this case, we call it primary effluent, is wastewater that is treated in the primary basins. So we call it primary effluent. And then we have different qualities of primary effluent at Hyperion or different quality of feed at Hyperion. So we can feed the facility with different qualities. So then we have a pump station downstream of the primary basins or primary clarifiers. We have a fine screen to remove any large debris that is remained in the wastewater. And then we have our bioreactor, right? So this is an advanced bioreactor as opposed to the conventional, like existing bioreactor. So this is a process, we call it nitrification, denitrification, and the main objective is not only to remove organics, but also to remove nitrogen-based contaminants, or what we called nitrogenous constituents, like nitrite, nitrate, ammonia, etc. Right? Because with the conventional treatment, like the existing treatment, you won't be able to remove a lot of nitrogenous constituents, but with this advanced bioreactor, you will be able to remove nitrogenous constituents in addition to the organics. So that's the bioreactor. Then we have the 3 membrane separation systems that I mentioned earlier. And downstream of that, we have 2 reverse osmosis trains. So what you don't see here is the UV ultraviolet advanced oxidation process that I mentioned earlier, but there's going to be a small unit as part of the treatment process for MBR pilot facility. Next slide, please. So yeah, this is a schematic of the MBR pilot facility. So you can see the bioreactor, you can see the MBR or membrane bioreactor separation systems. Kimia, if you can point out, to the, so let's start from the beginning. If you can point out to the fine screens, and then bioreactor, then MBR separation systems, the 3 systems that I mentioned, and reverse osmosis. There you go. Thank you. And we have, we're using some chemical for the treatment process. So the remaining are the chemicals for the treatment process. Next slide, please. Okay, so this is a summary of, testing schedule. So we have developed a testing and monitoring plan for the MBR pilot facility. And we are testing, the 2 or 3 components, a membrane bioreactor, reverse osmosis, without getting to too much detail. So we need to have like a process acclimation period so that the bugs in the microorganisms, they develop, and then develop, design criteria for high loading, like high organics or high nitrogen, and low loading, right? Because I mentioned that we have different qualities of, feed or wastewater. And then reverse osmosis, reverse osmosis has different recovery percentage. So obviously, our aim is to maximize the recovery. The more that we can recover, the better. But there are some challenges, right? If we push it too hard, we're risking membrane fouling and other issues. Next slide. So again, we have developed a testing and monitoring plan for MBR pilot facility. So we're working closely with regulators, including Los Angeles Regional Water Quality Control Board, the State Water Resources Control Board. We have formed an independent advisory panel, which is administered by National Water Research Institute for the regulatory approval of Hyperion MBR pilot facility that I mentioned. And these are the project partners that I mentioned earlier, right? So LASAN, LEDWP, and West Basin. and they are all contributing to our testing and monitoring plan. Next slide, please.
Oh, sorry, Nasir. So I wanted to do a quick time check. We're 20 minutes before closing time, and I know we have we may potentially have a few questions.
Sure.
So I believe you may do you mind if we come back to the finishing presentation after we kind of go through some of the housekeeping? So I wanted to also apologize for that. So for the attendees who are listening in, please go ahead and change your name with your school affiliation so we can kind of keep track of where the questions are coming from and tally up the attendance. So it will be your first name, last name, separated by the university or college that you're attending. For those of you that are attending from the sanitation, we got your name, so you don't need to do that. So with that, we usually get answers trickling in after we conclude the presentation. So let's, I wanted to stop here a little bit. And also another reason is I do have a few other questions too. And we also have a slide to share with you as well. So, with that, let me switch over to the general slides, if it's okay with you, Nasir and Kimia, and if time allows, we can go back to finishing a few slides left, I believe that you have. So let me go ahead and pull up my presentation really quick. Again, if you haven't done so, please go ahead and change your name with the school abbreviation behind it. And this is probably the time that you can ask questions in the Q&A box. I have received some questions from folks that are interested in the presentation, including myself and other attendees as well. So we'll go over those questions. But I also wanted to, again, highlight the really important work that Nasir and Kimia are doing. So we're closing the loop, as if I have to quote Kimia, we're getting a lot of water, imported water. 95% of the water is coming from out of this region. And it's such a shame to see it go to waste, go unused. I wouldn't say waste, unused. And we got to really tap into that. And this is a really great effort to, be the lead in the region. Hyperion, as the name implies, is a very big water reclamation facility, and just conveniently located right at the where the ocean meets the land. And we still have resources and land to expand on existing treatment facility. So if you think about it from engineering planning and engineering time, 2035 is just around the corner. We don't really have that much time, so I can assume that it's full speed ahead coming to Hyperion in order to fully reclaim the water. So, with that, we have a lot of exciting career opportunities. I wanted to kind of highlight the areas that we are hiring. I think this kind of maybe answer one of the questions that the attendees have. I believe, so we'll, switch gears a little bit and start with the questions related to the hiring. So one question that I see from Armin, again, I apologize if I mispronounce your name. The question is, what are the environmental engineering opportunities available in LA Sanitation? So I'm going to get right to the point. We hire several, positions. So the focus of our today's recruitment is the environmental engineering associate. So these are the basic requirements for you to be considered an environmental engineering associate with the city of LA. It goes from associate 1, 2, 3, 4. Go through the series based on your experience and your requirements. So if you have a PE, starting in, you have a PE bonus. Basic requirements are you have to have at least a bachelor's degree, or get an EIT, or you should be working to get an EIT within 2 years of employment with the city. That is the requirement to retain employment with the city. You must be at least 18 years old, have a proof of identity with legal right to work in the US. And again, I can't emphasize enough on EIT. This is a requirement to remain applying within the city. So please go ahead while you're brain is fresh with the schoolwork, go ahead and get your EIT as soon as you can. Whether you end up working for the city or consultant or any area, EIT is very desirable. And it is a hybrid position. So we have a telecommuting option, and we have work site throughout the city. But you do have to be located or residing within the commuting distance from your office, in that sense. So you should be located within a reasonable distance from your work site. We have several work sites throughout the city. So that is for the environmental engineering associate position. We also have, for those who are still completing your classes, student engineer position. It is a full, you must be a full-time student. Your salaries are based on your standing from freshman to senior. And it is not an internship. It is a real work environment. You will be assigned to do MBR and other areas that city is taking the lead on. It is a part-time position, which means that you will be allowed to work up to 950 hours, which is close to 20 hours a week. We do have flexible work schedule, and we work around your school calendar. If you have midterm and final that you need to take some time off, we're flexible with that. The salaries start from hourly $20.77 an hour to $32.25 an hour, depending on your standing, whether you're a senior or junior or freshman. Again, the same requirement. You must be located within commuting distance from your work site, because imagine Hyperion, you do have to come in and do the field work. So it's impossible for to do the full telecommuting in this sense. Here are some other recruitment events that we are hosting. So if you come in SWE Regional and SBE, BEA, SHPE Regional, and we also are hosting on campus Fall Engineering and Technical Fair, Cal State Long Beach, no, I apologize, Cal State LA Internship and Career Expo, UC Riverside. If you don't see any of those activities at your school, please check with your career center for more information. We just finished a really successful engineering day with a lot of attendees and a lot of applications, and it was free via Zoom. And if you were in attendance, thanks for attending. So that was last Saturday. And I'll leave it out here for you to get more information. You can download the application at these locations, going to your career center, going through your school handshake system, attending the conferences and finding our booths. And if you attended the engineering day, you should have received the information. This is what the application will look like. Also to highlight the diverse area that sanitation is taking the lead in. Kimmy and Nadia Nasir talk about the clean water program, where we have advanced water recycling. We have water conveyance system where it focuses on the sewer lines, sewer pipes, construction planning and engineering for that, full water reclamation plants that city operates. We also have wastewater engineering and design that basically look at the design planning of the conveyance system. We also have a solid resources, which is something quite a branch. If you consider waste, you have solid waste and water waste, and we also take care of the solid waste, and it's a big program. Taking care of 4 million plus residents and businesses within the city, as important as the wastewater program. We also manage the stormwater. Stormwater, when you think about it, it's nice and cloudy. We just had a storm that it doesn't rain that much. When it rains, it pours, and we have to have an infrastructure in place. And again, the rainwater is a resource that we don't want to throw away. So, there's a lot of water capture and recycling for the stormwater activities as well. And lastly, we have for a whole organization, we have to have customer care, financial management division, and we are faced with regulatory challenges, and we are regulated by state and other local agencies. So we do have a division dedicated to address the regulatory affairs for the city. And we have an executive team that basically makes decisions for our city's future and current projects. Customer care, 24/7 operation. We do hire engineers and customer care for database management and IT. So those are the areas. And again, more information on Project Green Leadership. These are the two staff and faces of the PGL, and these are their contact information. You can feel free to reach out to them with any questions that you may have for your career or your hiring process. Deandra and Ani are very reachable and very personable. So again, just to highlight where we're at, we just wrapped up the second of the 6 Tech Talk series today, focusing on the future of our survival. Water is our lifeline, and we've been relying on water, since the dawn of civilization. Our livelihood depends on where we can find water, and Nasir and Kimia are making it possible for us to basically sustain and survive in the future. So very interesting topic. The next week, we're going to be talking about the climate change and how we protect our watersheds, which kind of touch with the stormwater issues that we have. So with that, I believe our coordinator will be sending you an email with all the information that we just shared. If you are registered through Zoom, you will be receiving those information as well. So that's a long-winded answer to the first question that we have. And let me read out another question from the same person, Armin. I'm a civil engineering student at CSUN. I want to know what are the job opportunities in environmental engineering. So Armin, I hope we answer your question. Student engineer, if you're still going to school or if you're about to graduate, environmental engineering associate. We also have other areas for non-engineers, such as environmental scientists, environmental compliance inspectors, and you go to city website, you will see the information. So I'm gonna click on the answer live for those 2 questions that we just answered. Moving on to the next one from Edith. Do you know any other recycling purposes besides gray water system and drip irrigation that a homeowner can use to conserve water? So this is still in the water recycling, but kind of falls in the individual, I would say, satellite facility water recycling. Anyway, you can use, I myself, we kind of have our own manual watering. So if you do not have a sprinkler system, that's a big water saver, that reduces your water footprint. Like you said, it's a drip irrigation. Not turning your faucet on while you're brushing your teeth is not a water saver. And the gray water, it could be used. There's a lot of people have different perspective on how you can use gray water effectively, but it's really up to the homeowner's discretion how easy it is. Some people don't live in a single family household. They live in an apartment, so it's really hard to make those changes. But be mindful of it. Pretty much, whatever we do, it's going to be make a great impact over time. So the next question that I see from the same person, Edith, how much electricity is generated from biogas that is collected during the wastewater treatment process? So I think, that would maybe the answer that Nasir and Kimia may have. So I'll hand it over to you folks.
Yeah, I can quickly answer. So 20 megawatts. Right now, we can produce up to 20 megawatts of electricity using biogas from Hyperion.
So Nasir, how much is it compared to the actual usage of the plant?
Like almost the same, so it's sort of, yeah, so the power demand is between 18 to 20 megawatts, and same thing with our biogas production.
That's amazing, because we're basically supplying our own energy with what we produce.
Absolutely.
Wow, okay. All right, so the next one is from Susan. Are pharmaceuticals removed with the current and future treatment process? If not, what plans does LASAN have in this regard? So I'll hand it over again to Nasir and Kimia.
Can you repeat the question one more time?
Yes, so are the pharmaceuticals removed with the current and future processes? If they're not removed, what do we plan to do to remove the pharmaceuticals? So I guess contaminants of emerging concerns.
Sure. Yeah. So yeah, the treatment process, that we're proposing, Again, MBR, RO, UVAOP, especially RO and UVAOP, and especially UVAOP. UVAOP is very effective in terms of removing what we call contaminants or constituents of emerging concern, including pharmaceuticals.
So, Nasir, is it true that we have to demonstrate with a pilot project on how everything works out in terms of how much we can remove before we kind of go into the full-blown recycling of 350 plus MGD?
That's absolutely correct. So that's the purpose of that's why we call it a pilot. So pretty much we're testing things in a smaller scale, 1 million gallon per day, just to make sure like those concepts they're applicable to the big project, right? Hyperion 2035.
Right. Okay, so that makes sense when we start out small and see how we can implement this program, collect information, and with that use that information to start off the full-blown full recycling. So it's really good. We're getting close to 1 o'clock mark, and I see a few more questions still. So let me go ahead and jump into ISO's question. Is LASAN currently accepting applications for the student engineers positions? I believe yes, we are. We may have just finished the first round, but we continue to accept applications, I believe, for the winter semester, winter quarter. So we just welcome the first of the engineers, which Lisa is a part of the recruits. So the next one will be kicking off in a few months. So moving on to another question from Fernando. With the upgrades that are coming with Hyperion, are there any recent developed mandate compounds of concern, so contaminants or emerging concerns that your team is looking to remove that wasn't previously treated or removed? So, I guess, what are the contaminants that are in the pipeline in the regulatory area that might be hitting us, when we have the full scale coming up, and are we ready for the challenge?
Yeah, and that's an excellent question. So just in summary, so the current treatment process is not able to remove some of the what we called refractory, like stubborn contaminant of concerns, such as like NDMA, pharmaceutical that was mentioned earlier, or it's not very effective in removing those constituents. But then there would be, with the future treatment process, there would be a wide range of CECs, constituents of emerging concerns, that the future system will be effectively and efficiently will be removing.
Excellent. So we do have 1 minute, so I'm the one that has a lot of questions still. So after 2035 Hyperion full recycle project, do you think we will be able to be self-sustaining, such as how we can provide our own energy for Hyperion? Would it provide enough supply to our demand?
So if we can continue being like self-sufficient in terms of energy, perhaps not, not at least not from biogas, right? Because this is such a significant and drastic improvement to the treatment process. And those additional treatment processes, they are, for the most part, the energy intensive. They require a lot of energy. So our energy demand is going to be tripled or even more. And the current biogas production would not be able to satisfy the demand. But look at the bright side. We're going to be receiving electricity. We're going to get our power from LADWP, Los Angeles Department of Water and Power, and they're changing their energy portfolio, right? So they're using more solar, more renewable, sustainable sources. So that's the bright side.
Great. Well, thanks again, Nasir and Kimia, for a very informative presentation. I learned a lot from you too. And for those who are attending, please join us back next week. We have we will have our Tech Talk series every Tuesday for 6 weeks. This is our second week. And again, next week, we will be talking about, let me go back to my notes. There it is. Countering climate change, a deeper look into protecting our watersheds. So we have a public counter that we look at the design plans and, approve the part with the Department of Building and Safety. We approve the design plans from developers and residents as well. And we make sure that everything we do is in line with our visions and goals, and we protect the public health and the environment in the stormwater way. So next week, we'll welcome Mr. Oval Hernandez, Michelle, and Ms. Sarah Garcia. So hope to see you again soon. I hope you learned as much as I did. And you will be receiving an email from our organizer with all the information that we shared today. And you can also find today's Tech Talk on YouTube. And the link will be provided in the email as well. So with that, again, it was good to have you, Nasir and Kimia, and thanks Lisa and Pam for assisting with the Tech Talk. So we're going to close the Zoom and hope to see some of you next week. Bye-bye.
Bye.
Thank you. Bye.